Today we're going to talk about solving second order linear differential equation having constant coefficients. So this is a homogeneous equation because it has 0 on the right hand side, and over here a, b, and c are constant. This is a second order differential equation because it has y double prime on it. In order to solve this differential equation, we need such a value for y that when it is differentiated, it gives the same value in different forms. So let's take y equals e to the power rt is that value, and when differentiated with respect to t, uh, and over here r is constant, we get y prime equals r e to the power rt, and we get y double prime equals r square e to the power rt. Now we plug in y prime, and y double prime in this original value, original equations. We get a r square e to the power rt plus b r e to the power rt plus c e to the power rt equals 0. Over here, e rt is common, so we take it out, and we have ert times ar square plus br plus c equals 0. Now we know ert can never be 0, so ar square plus br plus c must be 0, and this is in a quadratic equation forms. So we get two values of r from that equation, and from that two value we can have three cases for those values of r. So let's talk about the first case. The first case we have is distinct values of root of r1 and r2. The general formula is y equals c1 e r1t plus c2 e r2t. Here c1 and c2 are the two constants because it is in a second order differential equation, and the r1 and r2 are the values that we got from solving these equations right here. So let's take an example: y double prime minus 5y plus 6y equals 0. After solving it, we get the value 3 and 2 for the r, and we just plug that 3 and 2, r2 and 3 doesn't matter what order on this equation in order to find the value of c1 and c2. And we have the second case, which is a repeated root of r, that is r1 and r2 are equals. The general formula case for this case is y equals c1 r1t plus c2 t ert. Here we have t extra on the second form. This is the formula we get because we can't use the previous formula, this one for the second case, as it will end up just giving us one solutions, which is y equals c ert. Now uh, we can talk about how we got this formula by taking an example: y prime minus 4y plus 4y equals 0. This is a second order linear differential homogeneous equation, and this can be after solving we can write it in the form r squared minus 4r plus 4 equals to 0. And we after solving the value of r, we get r minus 2 whole square equals to 0, and from that we can get r equals to 2. Now let y1 be c1 e to the power 2t, and y2 be vt e to the power d. We already extra vt in order to get that equations. Now this 2 is just the r over here, and also we know that y equals y1 plus y2. Now differentiating this y2 with respect to t, we can just write vt as a v e to the power 2t. So after differentiating y2, we get y2 prime. Since this is a product of two functions, we get 2v dot et plus e2t dot v prime. We get v prime from differentiating the v. Now this is the product of two functions as well. So when we differentiate with y2 prime, in order to get y2 double prime, we get 4v e to t plus e to t times 2v1 from this product right here, and we get e to t times v double prime plus 2v prime dot e to t from this product of functions right here. Now This one, we're just simplifying in order to get this one, b prime dot e to t plus, and arranging it, this one. So now we have y2, y2 prime, and y2 double prime. Let's put the value of these y2, y2 prime, and y2 double prime in these functions right here. So we get, this one is y2 prime, so we just put in the y2 prime minus 4 from here, and value of y2 prime, value of y2 prime, plus, and then the 4 and the value of y, so 4 and the value of y. So we can see, uh, there are some terms that are common, and we can just add and subtract it. So we have 4v prime plus times 2, times e to t, and we have minus 4 times v prime e to t, so we can just cancel them out, and we have 4v times e to t plus 4v times e to t, that is 8b times e to t, and we have minus 4 times 2, which is 8b times 2t. So we can just cancel them out as well. So we have so the only term remaining from this equation is v double prime times e to t equals 0. That is this one right here. And we know that e to t can never be 0, so we have v double prime equals to 0. And we know that v is a function of t. So v is a function of t. We just wrote the v to make it easier. So we have v double prime equals 0. And in order to get v prime, we integrate the v double prime. So we get, when we integrate the v double prime, we get v prime. And we also need to integrate 0. So we get constant k1 from the 0 right here. So also we need to integrate v prime in order to get v. So after integrating the v prime, we get v equals, and we know when we integrate the constant k, we get k1t. Also we have plus 0 right here, so we get k2, and here k1 and k2 are both constants. We know, and also this is vt from right here. So we have to plug that value right, uh, for the y2. So we get y2 equals k1t plus k2t times e to t. So we, after simplifying and multiplying, we get y2 equals this value. So we know y equals y1 plus y2. So, and c1, c2, k1, k2 are constants. After just plugging the value in, we get y equals this value right here. And we know 2 equals r. So switching the value for r right here. So we get this general formula, which is the same as this one we get earlier. And the case, for the case third, we get complex roots of r, that is imaginary values, r equals lambda plus im. The general value formula is this one right here. And let's take an example, 2y prime plus 6y prime plus 8y equals 0. And where y, after the solving the values, we get r equals minus 6 over 4 plus minus 28i over 4. Here 6 over 4 is real numbers, this one right here, and 28 by 4 is the mu right here, which we can plug in right here. Okay.